So last class we have studied up to elastic limit. So today we will be studying Hooke's law. Hooke's law. Okay. So what does Hooke's law say? See, up to elastic limit, stress is proportional to strain, or stress by strain equal to constant. This is what is means this constant is called as coefficient of elasticity or modulus of elasticity. See, up to elastic limit, मतलब elastic limit पहले दिन आपको समझाया था कि elastic limit the maximum value of deforming force up to which a body behaves like a perfectly elastic body. Okay, so Hooke's law states that, means I'm not telling the law, I'm just stating what is mentioned in the law. See, up to elastic limit, up to elastic limit, stress is proportional to strain, or we can say stress divided by strain equal to constant. Now this constant is called coefficient of elasticity or modulus of elasticity. This constant is called as coefficient of elasticity or modulus of elasticity. Okay, stress by strain is coefficient of elasticity or modulus of elasticity. Now it depends on types of material, temperature of the body, pressure of impurities in the body. Okay, this coefficient of elasticity depends on what? Let's just write this. Depends on what? Material or type of material of the body. Type of material of the body. Okay. Depends on the type of material of the body, temperature of the body, presence of impurities in the body, presence of impurities in the body. Okay, presence of impurities in the body. Now see, I think I have told you in the last class that this strain is dimensionless and unitless quantity. Okay, but stress has dimension. We have determined the dimension of stress, that is ml inverse t to the power minus 2, and unit is Newton per meter square. So this okay, we did this. Now see this coefficient of elasticity, this does not depend on the stress or strain. Okay, what I mean to say is that this coefficient of elasticity, the constant that we are saying, it does not depend on the stress or strain. Okay, write this, just coefficient of elasticity does not depend on stress or strain. Okay, now there is some few like terms. Okay, now here comes the Young's modulus. Young's modulus, this is nothing. See, I have told you that stress by strain means constant, something constant. Like if suppose A is proportional to B, we take that A equal to BK, or A by B equal to K, and we take that K as constant. Okay, so here stress is proportional to strain up to the elastic limit. Remember this, up to elastic limit only. So here stress is proportional to strain. So what happens is that stress by strain is constant. Constant is called coefficient of elasticity or modulus of elasticity. Now comes Young's modulus, which is denoted by Y. And this Young's modulus means this is also some constant. Okay, what's constant is this? So this will be obviously stress by strain, but Young's modulus is longitudinal stress by longitudinal strain. Okay, now the dimension and unit of modulus of elasticity is same as that of the stress, because strain is unitless and dimensionless. Okay, I have to write that? Oh, no, you remember that. Now coming Bulk's modulus. Bulk's modulus, that is denoted by K or B, that is volume stress by volume strain. Now rigidity modulus is denoted by neta. Let's come rigidity modulus. Rigidity modulus, this is denoted by neta, which means shear stress by shear strain. So these are all types of constants or modulus of elasticity. Okay, suppose there is longitudinal stress and longitudinal strain, then it is told you that find the Young's modulus. Then you can simply find it by longitudinal stress by longitudinal strain. For different materials you have different this modulus. Okay, for every material this modulus are same. For steel it is suppose maybe 2 into 10 to the power 11, like that. Young's modulus I'm talking about. All the modulus are constant, that only I have told. Now stress by strain is, stress by strain is also called modulus of elasticity, and Young's modulus, that is longitudinal stress by longitudinal strain, Bulk's modulus, volume stress by volume strain, and we have rigidity modulus, that is shear stress by shear strain. Here comes another term that is known as Poisson's ratio. Poisson's ratio, that is denoted by sigma. Okay. Suppose there is a chain. Okay. Now suppose force is applied here, so it will elongate, and it will elongate like this. There will be both, means like the radius will also decrease, so that is, let's suppose the radius will be delta, decrease in radius delta r and increase in length delta L. Now when there is a longitudinal strain of a body, the lateral strain of body is also present, we can say that. So let us write it, when there is a longitudinal strain of the body, longitudinal strain of a body, then lateral strain of a body is also present. Okay, lateral strain of a body is also present. Now see, when elastic limit, within elastic limit we can say the ratio of lateral strain to longitudinal strain is constant, and that constant is called as Poisson's ratio. See, within elastic limit, the ratio of lateral strain, what I've said, lateral strain only, no? Ratio of lateral strain. The ratio of lateral strain and longitudinal strain is constant, and that constant is called as Poisson's ratio. So you can say that sigma equal to lateral strain divided by longitudinal strain. See, Why this is called Poisson's ratio but not modulus? Because modulus of elasticity means stress by strain. So we have divided, means there are number of types of modulus, and we have divided and one of the time is Young's modulus, which is longitudinal stress by longitudinal strain. We have Bulk's modulus, which is volume stress by volume strain, and we have rigidity modulus, shear stress by shear strain. So modulus of elasticity is of three types, but this Poisson's ratio means not stress by stress by strain, it is strain by strain. So you can understand that Poisson's ratio will have no unit, because this is strain by strain. So what unit you will have? Okay, it means we cannot call this as modulus of electricity. It is just elastic constant. It is not modulus of elasticity. Remember this. So this, among this Young's modulus, Bulk's modulus, and this Poisson's ratio, there are relations. So topic is relation. This means relation between Young's modulus, Poisson's ratio, and Bulk modulus. See, I am not going in the calculation. I am just stating the relations. First relation is y equal to 3k 1 minus 2 sigma. Second relation is shear stress के बीच में भी एक relation. Second relation is y equal to 2 neta into 1 plus sigma. This is sigma, bro, not alpha. Okay, and another relation we have 3 by y equal to 3 by neta plus 1 by k. See, this is the relation between Young's modulus, Bulk's modulus, and Poisson's ratio. This is the relation between Young's modulus, shear stress, and Poisson's ratio. And this is the relation between Young's modulus, shear strain, and what is this? K is what? I forgot. K is... oh, sorry. K is Bulk's modulus. Okay, so from these relations we can take out the limiting value of sigma, that is Poisson's ratio. So let us just take out the limiting value of sigma. See, we have got y equal to 3y equal to 3k 1 minus 2 sigma. Y is, we are getting, this is positive, and this whole term is also positive. See, this whole term is also positive. So this 1 minus 2 sigma should be positive. This, so see, this is positive. This means left hand side is also positive, right hand side is also positive. So 1 minus 2 sigma should also be positive. Yes or no? Let's see. Okay, let us just mark this as 1, 2, and 3. So we are using this first equation. So we are writing from 1, determining the limiting value of sigma. Okay, so we have got 1 minus 2 sigma, so it will be 1 minus 2 sigma greater than 0. So sigma will be greater than equal to 0, greater than equal to 1 by 2. Okay, now from equation 2 we have y equal to 2 neta 1 plus sigma. See, here also this is positive, and this is also positive, this whole term. So 1 plus sigma is also positive, so we can again say that 1 plus sigma greater than equal to 0. So sigma is greater than equal to minus 1. So the theoretical, that is, we have got from theoretical limit of sigma, we can say limit of sigma equal to is sigma less than equal to 1 by 2 and greater than equal to minus 1. But this is the theoretical limit of sigma, but actually there is a practical value of sigma is from practical value of sigma ranges between, this is same, but it can never be minus 1, because if sigma becomes minus 1, that is sigma becomes negative, then that means that the radius of the substance also increases when the length is means increasing, which is like never can happen. Suppose there is one rod, we are pulling the rod, and the radius of the rod when we are pulling, that is also increasing, and the length is also increasing. That can never happen. But Poisson's ratio is negative. That means that only, that with the length, the radius of the rod is also increasing. Okay, so suppose if volume of the body remains constant, then if someone asks you that show that sigma equal to 1 by 2, how will you do that? Let's do this. If volume of the body remains constant, then show that sigma equal to 1 by 2. Suppose someone is asking, show that sigma equal to 1 by 2. What will you do? We'll share that. Let us consider. You will first say that let us consider a rod of length L and radius R. So volume will be what? Volume will be radius of the cylinder, that is pi r square h की जगह में L लिख देंगे. Now, so you've got delta V will be what? Delta V will be pi r square delta L plus pi L into 2R into delta R. Nothing. We have just differentiated this. See, when we will differentiate this volume V pi r square by L, it will be 2 pi RL in the first case, and in the second case it will be pi r square pi r square delta L. Differentiation, I hope you know, that's why I have written it. If you don't know, see, V I am differentiating it, okay, so that it will delta V equal to, when we are differentiating this along what we say that with LL, so that will be pi r square delta L. Okay, and when we are differentiating this in respect to R, then it will be pi L will be separate and 2R will come. Okay, 2R will come, and since we are differentiating this, so delta R will be also there. That's why I have written that delta V equal to pi r square delta L plus pi L into 2R into delta R. Okay, so the volume remaining constant, we have to prove that when the volume is constant, the sigma is 1 by 2. So that means delta V equal to 0, there is change in volume is equal to 0. So we can say that pi r square delta L plus pi L 2R delta R equal to 0. So we'll get pi R delta L plus 2L delta R equal to 0. That is R delta L plus 2L delta R equal to 0, because this will go that side 0. So we'll get 2L delta R equal to minus R delta L. That becomes actually L delta R by minus R delta L equal to half. So that is what is suppose we can write this in this way, that minus delta R by R and delta L by L equal to half. We can write this, no, delta R by R delta L. See, we can do like this, no. See, suppose here is A by B by C by D. We can write this AD by BC. That is only I have done here, that L delta R by minus R delta R. This is only same, L minus L delta R by R into delta L. So this becomes for delta r by r and delta l by l. This minus is for decreasing of the radius. Okay, so delta r by r means lateral strain, and delta l by l means longitudinal strain. So this is what is sigma. So sigma equal to 1 by 2. That's proved. We'll get another relation. See, suppose there is one length rod and we're stretching the rod by tying one box whose mass is m, and so it will apply one force this side. So the force will be equal to the weight of the box. Let us suppose that the radius of the cylinder, this rod, is r. Radius is r and the length is l. So there will be increase in length. Suppose there will be increase in length. So let us suppose that as delta L. L is suspended and block of mass m is suspended. So F equal to this. The force is mg we have got. And Young's modulus means what? Longitudinal stress by longitudinal strain. Young's modulus. So longitudinal stress. Stress means what? I've said that F by L. So F by L, that is force by length. The stress means force per unit area. So this force is acting and it is L. So F by L. And what is strain? Strain, longitudinal strain is what? Delta dimension by the original dimension. So here longitudinal strain is happening. So delta L by L. So we'll get F into L by A into delta L. So what we'll actually get, that is delta L equal to F into L by A into Y. That is mgl by pi r square y. This is one important formula. Remember this. We will be doing numericals on this in the next class. Okay, thank you.